Hello, welcome back. Now we're going to do today, we're going over arcs and sectors, areas of circles and sectors. This is very similar to 10.1b, the lengths of arcs. The only thing is we tweak it a little bit. We're doing area now instead of circumference. Now what you're going to be able to do at the end of this lesson is define the area of a circle, find the area of a circle, understand what a circle sector is, know what it actually is, and then find the circle sector of any circle based on what its central angle measurement is, as well as the circle circumference. So, let us start with this do now. Why don't you guys attempt 10.1c. See if you learned anything last lesson. So, you're finding the arc lengths for A and B. Let's see if you got it right. So, first thing you have to do is you have to remember the formula. Arc length of AB equals whatever the measure is over 360 times 2 pi r. So, you have the central angle over 360 to get your percentage, and then 2 pi r is your circumference. So, very simply, we have AB right there, which is 80 degrees. All right, over 360 times 2 pi, and your radius there is 16. Type it all into your calculator. 80 divided by 360 times 2, pi button 16. You get 22.3 as an answer. Very good. Let's look at B. AB, once again, is the minor arc, not the major arc. Remember, if it has 3 letters, then you could be above 180 degrees. That's how come you're using the smaller arc, not the bigger arc. So we just simply have 162, which is our central angle, 2 pi times 9, which is our radius, 162 divided by 360 times 2, pi button 9, and it equals 25.4. All right, and that's all you had to do. Hopefully you got both of them right. Now let's get into our lesson. The first thing you need to know, what is exactly the sector of a circle? So, what do you think it is? Let your answer real quick. All right, if you said it's a portion of the area of a circle, you were correct. All right, so it's just a part of the area of a circle. It's usually constrained by 2 different radii. The whole entire thing would be your area, and then the little piece would be your sector. So a theorem. You guys remember what the formula is for area of a circle? It is pi times the square of the radius. So if this is our radius, it is pi times r squared button, okay? So this is our radius. You take pi button, r button, whatever there is, say it's like 8, and then you do 8 squared, and then that gives you your answer. So let's do some examples. The first 3 examples are going to show us how to find the area of a circle. So using the formula right there, why don't you guys try to fill that in, see if you got it? All right. 4.2 is our radius, so pi times 4.2 squared. Now the meters is just, that's what M stands for, it's just a unit of measurement. So when you get that, you square 4.2, you get 17.64. I just went to the 100th place just so I didn't go crazy. Typically you would just multiply pi at the same time, and you get 55.4. Now notice it's square meters. Anytime you deal with units and area, it's squares, like square meters, square inches, square feet, square miles, all that's area. All right, so when you guys try 2, 3, and 4, 4 is the only one that may give you a little bit of trouble. Let's see what you got. Area is pi r squared, so pi 18 squared. Type it in your calculator, you got 1017.9. Do this in one fell swoop. You don't need the steps, all right? Problem 3. Pi times, radius is 7 squared, 49 pi, or 153.9. Got it? All right, let's look at 4. This right here is your diameter. So we can't use the diameter in this formula, we need the radius. So what you have to do is you have to divide it by 2. So the radius is half the diameter, so half of 13 is 6.5. Now we plug it into our equation, pi times 6.5 squared, and you get 132.7. You guys got it? Hopefully you do. And let's go backwards now. Now what you're doing is you have the formula for area. Area equals pi r squared. I'm asking you to find the diameter of that circle given the area. You could do this all backwards. So first thing you do is you want to substitute in what for A? Well, our area right there is 201 inches squared. So 201 square inches equals pi r squared. So the next step here is you take whatever the area is, and since we're trying to isolate r, you divide whatever is next to r squared. You do PEMDAS backwards. So divide each side by pi. All right, so 201 divided by pi is 63.98. Next step, you want to find the positive square root. So r squared is this. So you do square root of 63.98. And you get the radius to be 7.999, which is about 8. All right, so it's about 8 inches. All right, so the diameter is twice the radius. So it's 2 times 8, which happens to be 16. All right, that wasn't too difficult, was it? So why don't you guys attempt problems 6 through 9 real quick, where I get my pointer. There it is. All right, so hopefully you guys got these answers. So you got pi 16 equals pi r squared. Divide both sides by pi. You get 5.1 equals r squared. Take the square root of 5.1, and you get 2.3. All right. Problem 7. To find the diameter, you do 2 times the radius. So 2 times 2.3 is 4.6. All right. Radius, diameter is too much. 2 times it. 46 equals pi r squared. Divide both sides by pi. 14.6 equals r squared. Square root, which is second x squared button on your calculator, 14.6. And you get 3.8. All right, to find the diameter, 2 times 3.8 is 7.6. All right, now this one has a 14 pi attached to it. So 14 pi equals pi r squared. What do you think 14 pi divided by pi is? Well, the pi's just cancel out. So you're left with 14 equals r squared. So you just take the square root of 14. Square root of 14 equals 3.7. Find the diameter, you multiply that by 2, and you get 7.4. 16 pi. 16 pi equals pi r squared. Divide both things by pi. 16 equals r squared. You guys know square root of 16 off the top of your head? It is indeed 4. So when you find the diameter, it's 2 times 4, or 8. All good? Awesome. Now we can go kick it up a notch. So that's simple area problems. Now we're going to find the area of an actual sector. Almost identical, I say almost identical, same concept as the length of an arc. So the ratio of an area of a circle to the area of the whole circle. So what you're doing is you're finding, like, the percentage again is equal to the ratio of the measure of the intercepted arc to 360. So what this means is it's the area of this purple piece, right? A, P, B, almost say it like a triangle, over pi r squared, area of the whole entire circle. All right, so that gives you percentage, equals the actual measurement here, the measurement of this arc, which is the measurement of the central angle, over 360. So it's pretty much saying both these ratios are the same. Okay, the ratio of the angle to the whole thing, and the ratio of the area to the whole area. All right, now we could make an equation for this, the area of the actual sector, by multiplying both sides by pi r squared, equals the measure of AB over 360 times pi r squared. So 3 simple steps to do this. The first step is you want to find the percent of the circle. Take whatever the inside angle is divided by 360. That gives you the percentage. Step 2, find the area of a circle, pi r squared. And the third step is you take these 2 numbers that you get here and you multiply them together to get the sector area. And you're going to do this all in one fell swoop. All right? Let's see if you guys can handle it. Find the areas of the sectors formed by RQS and RPS. So I'm going to bring you through the 2 steps real quick, and let's see if we can do it. So step 1, we're going to try to find the area formed by RQS, this purple sector right here. So we find the measures of the major and minor arcs. So what is the measure of the minor arc here? It is indeed 63, because 63 is the smaller angle. So that means the measure of the arc is the same as the measure of the central angle, which is 63. Now if we want to find the measure of this big arc, the major arc, okay, because we're going to do them both, you do what? Total area is, total angles in a circle is 360 minus 63, and you get the whole entire thing right here, from here all the way around, is 297. Add up 360. Step 2, and typically you're just doing one of these 2, not both, but we'll take care of both at the same time. Find the areas of the small and large sectors. So the measure of RS over 360, 63 divided by 360 times the area. Pi, what's the radius here? 5 squared. One thing, 63 divided by 360 times pi button, 5 squared, equals 13.7. That's it. Why don't you try the large sector? Hopefully you use this 270, the large sector right here is the red. Using the 297 divided by 360 times pi, same radius. Radius is always the same in a circle. And you should get 64.8. If you added these together, it would be the total the total area of this whole circle. It'd be pretty much pi times 5 squared. All right. Why don't you guys attempt problem number 11? Find the measure of the minor arc. Got it? Minor arc here is 130. So what you're going to do here is 130 divided by 360 times pi. Radius is 11 squared. Type it into your calculator, and you should have gotten 137.3. All right? Pretty easy to do. Now I want you guys to attempt a couple examples. All right? So try 12 through 15. Pause, do the problems, and then let's see if you're ready. Ready to go? Hopefully on pause, and now you're good. So we're finding the shaded area in all these cases. In this case, it's 163 divided by 360 times pi, 6 squared. It's all calculator work, 51.2. All right, right here. What's our angle? 26 divided by 360 times pi, 142 squared. Type in your calculator, 4,575.1. Easy. All this stuff is very simple. Right here, 142 divided by 360 times pi, 8 squared, 79.3. And then problem number 15, 28 divided by 360, pi 12 squared, 35.2. Notice, same exact formula every single time. Very simple. All right, once you guys try these four, pause. All right, taking it up just a little bit here. Same easy problem, 96 divided by 360, pi 24 squared, 482.5. Hopefully you got that. This one now, there's no angle. But you got a straight line here, and this 60 is the whole entire distance, but you need the radius. So you divide 60 divided by 2, and you get 30. So that gives you your radius. Next thing you have to do is you have to find this angle. How much of this circle is that? Well, since this is a semicircle, that means it's 180 degrees. 180 divided by 360 times pi 30 squared. You should have got 1,413.7. All right? Little tricky, but remember, semicircle is 180 over 360, or you can just say half. Problem 18. 40 is not the angle we're looking for. That's the minor arc. We're looking for the major arc. So you have to find out what the angle right here is before you do anything, because that's the shaded portion. So 40 divided by 360 times pi 28 squared, 126.7 is incorrect. I don't know why I have that done. What you should have actually done here is 320 divided by 360 times pi 28 squared, and that gives you something else. I don't know off the top of my head, but you guys got it right. 38 divided by 2, find the radius here, which is 19. All right. 100 divided by 360 times pi, 19 squared, and that should give you 603.2. All right, good? Correct, 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 incorrect. See, everyone makes mistakes. Do 20 through 23. All right, let's go over it. 304 is not the angle you're looking for. You're looking for the minor arc, so you subtract 360 from 304. 304 from 360, 56. 56 over 360 times pi 7 squared gives you 23.9. 21. 124 is not the angle we're looking for. We're looking for this angle. Since this whole thing right here is 180, 180 minus 124, diameters gives you 180, semicircle. The angle we're looking for is 56. 84 divided by 2, right, because this is the diameter, gives us 42. So 56 over 360 times pi, 42 squared, gives you 862.1. Got it? Right here, since this is 270, to find this angle, 360 minus 270 gives you 90. 90 divided by 360 is pi 15 squared. And your answer is 126 points. And the last one, since this is 90, this angle is 360 minus 90, 270. 270 divided by 360 times pi 16 squared gives you 603.2. All right? Last two difficult ones. Find the purple, find the red. Good, let's go. First one right here. 48 plus 48 is 96. Why is it 48, 48? Because these two angles are vertical angles. So 96 times pi, 558 squared, gives you 2,818.2. Right here. 180 minus 1764 should have given you your 46, right? Because 180 minus 134 is 46. So this is 46, this is 180. Take the two angles together because you're going to use all the angles addition. 226. So this is 100, so half of 100 is 50. 226 divided by 360 times pi 50 squared is 4,930.8. All right, so you use these two angles and the semicircle being 180 to find the 46. Add the angles together because they're both shaded, and then find the radius. Got it? And that's all you have to do. So why don't you guys attempt these homework problems? And there we are, done for the day. Find the area of the circle. Pi times 5 squared is indeed 78.5 square inches. 2 dashes inches, 1 dash feet. Pi times 16 feet squared is 201.1 square feet. Pi times 23 squared is 415.5 square centimeters. And then the last one, 1.5 squared times 5 is 7.1 kilometers squared. Got it? Nice and easy. Find the radius or diameter of a circle with the following area. So, 154, which is your area, equals pi r squared. Divide by pi. Square root of that is 7 meters. Radius and diameters are just in meters, feet. There is no squared. The squared is when you're dealing with area. And then if you were doing cubic, that would be volume. 380 divided by pi. Square root of that is 11. Only use the positive answer. 678. Now pi divided by pi just gives you 676. And you get 26 centimeters. Last three, the three important ones. 60 over 360 times pi 10 squared, 52.4. If this is 256 here, this is 360 minus 256, which is 104. 104 divided by 360 times pi 14 squared is 177.9. And then this one, 137 divided by 360 times pi 28 squared gives you 937.3. Right? And that is everything we need to do. So hopefully you guys learned something. Hopefully you're able to apply this sometime somewhere. And until next time, we will